welcome to my channel. Today we'll discuss the ordinary least square method. So it is a part of econometrics and it is commonly known as OLS, ordinary least square method. Now, it is a common method to estimate the parameters of a linear model. So in a linear model, the most important parameters are alpha and beta, that means the intercept of the line, and the gradient or the rate of change of the line, which are important to estimate. And those parameters are to be estimated based on the assumptions that we have already discussed in the earlier lecture. That that mean of the errors should be 0, then covariances should be 0 and variance should be a constant. So when a line is drawn, when a average line is drawn, and if we put the data, that means coordinates, pairs of y and x on the scatter, then there will be n number of coordinates, and it is not possible for a straight line to pass through all the points. So we will have to estimate the straight line in such a way, we should draw the straight line in such a way that the line will divide the scatter into 2 equal halves, and the sum of the square of the errors will be minimum. So we'll discuss now. So we'll have to keep in mind the assumptions of drawing a straight line through or with the help of ordinary least square method. So suppose y is a variable, dependent variable, and x is an independent variable. So there will be different pairs. So when x1, suppose it is a production and it is labor. So if this much labor is put or appointed, production will be y1, this much. Then when labor will be increased, then production will be this much, like that. So for n number of pairs or observations between y, production, and input, so we'll have the coordinates in the graph representing y and x. And for this, the average of y will be 1 by n summation yi. So if you sum up, divided by n, this is the average. Similarly, for average of x, it is summation xi divided by n. So the estimated line is y estimated is equal to alpha estimated plus beta estimated x, and alpha and beta estimates are estimates of unknown parameters alpha and beta. So this alpha and beta will be estimated based on least square method. Now if we see the scatter diagram, so two quadrants, x and y. So x bar is the average, x average is this much, and y average is this much. So if we join, so this point will be point of intersection of both the averages. So the line which will pass through this point of intersection, we call it the average line or estimated line. Now, when there will be other points of x and y, that is pair of x and y, as you have said that pairs will be n number of pairs. Suppose one pair is this. Suppose x input has been increased to t, that means OT. So the point, the y will be somewhere here, and this is called, that means the difference between the p and the point on average line is called error. Actually, the point should be on the line, but data may be such that this point will not be on the line. It may be below the line or above the line. Suppose production is very less, so it will be below the line. If production is high, it will be above the line. So error E is equal to P minus R. If this point is P, and this point is R, so error is P minus R. Now, for any point, ith point, that means error in the ith point, EI is equal to YI minus YI bar. Now this error may be positive or negative. As I say, if the point is above the line, it is positive, and if it is below the line, it is negative. Now, summation of the square of the error term is non-negative, it is positive, because whether error is positive or negative, if we square it, positive will become positive, and if we square the negative error, it will also be positive. So when we will sum it, then sum EI square is positive, it is called non-negative or positive. So this means sum of the square of the error term is the function of estimated alpha and estimated beta. So value of estimated alpha and beta will influence the sum of square of the error term. Okay. Now, why it is so what is alpha? Alpha is nothing but the intercept. So 0 to this point, it is called intercept. And gradient of the line or slope of the line is beta. So when alpha and beta will change, necessarily estimated y will be changed, and it will affect the error. So sum EI square is non-negative, and sum EI square will be influenced by the values of estimated alpha and beta. Now, principle is that sum EI square, that means sum of the square of error term, should be the least. The meaning is that if sum of the square is least, necessarily the scatter, if we put all the points, it will be a scatter. So scatter will be 2 equal halves. Now, necessary condition, what will be minimum, that means what is the minimum values. So how to minimize this? So we'll have to find out the list. So that means we'll have to find out the minimum values of this. Now the necessary condition is that the partial derivative with respect to alpha and beta should be put to 0. So if we remember the necessary and sufficient condition of maxima and minima, or the minima, that the first derivative should be 0 and second derivative is positive. So necessary condition is that the partial derivative with respect to alpha and beta should be put to 0. So this means summation ei square, that means sum of the square of the error term for each observation or n number of observations is equal to summation ei square is equal to sum yi minus yi estimated yi square. So this is equal to this is equal to what we have got it, yi minus yi means estimated alpha. We have got it earlier, that this one. So y hat means estimated alpha minus estimated beta x square. So we must follow the minimization criteria with respect to alpha head and beta head, estimated alpha and estimated beta. So we'll have to minimize the sum of the square of the error term with respect to alpha and beta. So to do this, we must remember the minimization and maximization criteria. So in case of minimization, the partial derivative should be put to 0, while the second derivative is positive. So in this case, ei square, we have got that summation ei square, nothing but yi minus estimated yi square. So partial derivative with respect to this. Now here we'll have to use the chain rule. So we discuss in derivation about the chain rule. So what is chain rule is that now if we consider this as u, yi minus alpha head minus beta head xi is equal to u, so this will be u square. Now to derive with respect to alpha and beta, summation ei square by delta summation ei square by delta alpha is equal to delta summation ei square by delta u into delta u by delta alpha. So this will be cancelled. Ultimately it will be delta ei square by delta alpha. Okay. So similarly, with respect to beta, delta ei square by delta beta head is equal to delta summation ei square by delta u into delta u by delta beta head. So when we will have the partial derivative with respect to alpha, then it is minus 2 because it is square. It is square, so that means u square, that means 2u, and with respect to alpha is minus 1. So minus 1 is coming here, then and it has become minus 2. You can do the homework. So minus 2 summation yi minus alpha head minus beta head xi put to 0, because first derivative should be put to 0. So similarly with respect to beta head, minus 2 summation xi into yi minus alpha head minus beta head xi is equal to 0. Okay. Now from this is equal to this and this is equal to this. From this we can develop two normal equations. Now putting the values of summation yi, summation xi yi, summation xi and summation xi square from sample observations. So if we take the data on y and x, then sum of y, you add the series, the number of observations, suppose n, there are n number of observations, so you add, then summation xi yi, so you have y and x series, so y1 x1, y2 x2, y3 x3, so on up to yn xn, sum of the result, sum of the result, then summation xi and summation xi square, that means x data x1, x2, so on up to xn, square it from sample observations, and we can get alpha head and beta head. Now summation yi from these two equations, we can develop this, that summation yi is equal to n alpha head plus beta head summation xi. Okay, this is minus 2 into this is equal to 0. This means this is equal to, if we divide 0 by 2, this is equal to this, and multiply both sides by minus 1, it will be positive, and similarly this. So summation yi is equal to n alpha plus beta head summation xi, then summation xi yi is equal to alpha summation xi plus beta head summation xi square. Now if we take this from mean deviation, so we'll have the x series and find out the mean of this, average of this, and deviate the mean from each variable, each observation, square it, then sum it and square it, okay, from mean deviation. So sum of mean deviation is 0. Now what is alpha head? What is alpha head? Summation y by n. So this is nothing but average of this, and divided by n, it becomes beta head x bar. So you take this term in right side and transfer these terms to left side, divided by n. So you will get alpha head is equal to y bar minus beta head x bar. Okay, beta head x bar. Then beta head from this xi yi, if we take it from the deviated xi and yi, is equal to summation xi square, because in that case it will be 0. Mean deviation will be 0, so this term will be 0. So summation xi yi mean deviated divided by summation xi square is equal to beta head. So the estimated line will be y head, estimated y is equal to alpha head plus beta head x. So these two equations are known as the two normal equations of ordinary d square, which is very common in estimation. Two normal equations, or using two normal equations, we can derive the value of estimated alpha and estimated beta. So we'll have to remember these two equations. So to get estimated alpha, transfer these terms towards left side, to the minus beta hat summation xi, and divide by n. Then it will be y bar. Summation y divided by n means y bar, and beta hat divided by beta hat into sum xi divided by n means x bar. So this term will be x bar, and here this term will be y bar, and this is beta hat x bar. So this is alpha. Okay. And beta hat from the second equations, take it from mean deviation. When it is mean deviated, it is 0. So this divided by summation xi square is equal to beta hat. So this way we can get the estimated value of y is equal to alpha hat plus beta hat x. So we have to remember these things. Generally, for the students of econometrics, these two normal equations, they should remember at any time. So this is all about the ordinary least squares. We'll go for the properties of the estimates, properties of alpha and beta estimates. In the next lecture we'll get. And for details, go to the PDF. And thank you very much. And go on watching and subscribe and share. Thank you.